Right, guys. So, manufacturer computer components wishes to estimate the proportion P of its present stock of components that are defective. A random sample of 500 components is selected and 10 are found to be defective. Construct a 95% confidence interval for P proportion of all components that are defective, right? So, let me explain what we're doing, right? So we're currently asked just to do the 95. The goal of the question is the 95% confidence interval. Are we cool with that? Now, when you see the word 95% confidence interval, when you see that piece of information there, you know what you're doing. You're going to be doing 1 over the square root of n. Is that cool, you guys? So let's start off with part 1, margin of error. What's the formula for the margin of error again, lads? Margin of error formula? It's up here. What root? So 1 over the square root of n, which is 1 over the square root of what? For this question? Yep. Throw it into the calculator. And you get 0.045. Now what is 0.045 if you were to change that into a percentage? Anybody know? I don't know. What is it? 4.5%. You just multiply it by 100 and it converts it back into a percentage. It's 4.5%. Is that okay? So that is your that's your error, so to speak. So that's your margin of error. Right. What's our actual statistic or proportion? How many of them were found to be defective? It's in the question. 10 out of how many? 10 out of 500. What is 10 out of 500? 0.02. Wait a minute. 10 out of 0.02. 10 out of 500. And 1 out of square root of 0.045. Yeah. Here we go. It's not. This question was not a good question to start off, right? Here we go. So what did we do last time? We added it on and we subtracted it, right? And that's exactly what we're going to do this time. Okay. So we're going to get 0.2 and we're going to add on 0.045. And what does that come? 0.065. Is that all right? And then what about the other one? We have to take it away, don't we? 0.02 take away 0.045. And that's minus 0.025. Now, this is the first negative answer I've ever gotten in my life. I'm taught honors for 10 years odd now, or 13 years. I've never had to do this before. Okay? Now, here's what's happening. What we're saying is your chance being accurate, you're 95% sure the answer lies somewhere between 6.5% and negative 2.5%. Now, what's the problem with negative 2.5%? It's not possible. So what would I do with that? I'd turn it into a 0. I'd say your answer is somewhere between 0 and 6.5%. Right? First time I ever had to deal with that. Now, let's have a look at another one. I wouldn't say so. All right, you guys try to. You're going to use 1 over root n because it's the 95% confidence interval. And you have it as a percentage at the moment. Okay? So you know that your p-value is either 27% or your p-value is 0.27. Okay? All right, margin of error 1 over the square root of 1,000. 1 over the square root of 1,000 is 1 divided by square root of 1,000 is 0.316. All right, or I'll round off to 0.032. otherwise known as 3.2%. Is that okay? I'd do one decimal place. I wouldn't go beyond that. Now, there's two ways I can present this answer. I can present this answer as decimals, or I can present it as percentages. I sometimes present it as both. Doesn't happen to have covered. Add on 3.2 to 27, and take away 3.2 from 27. Yep. And if you want to do it in decimal mode, so what we're basically saying is we're 95% sure that our answer of adults that were surveyed, our answer is somewhere between 23.8% and 30.2%. We're 95% confident that our answer is somewhere in there. Okay, it might not be 27 exactly, but somewhere in that range. We try another one. Now there is an extra layer to this. Okay, so I did 1, I did 4. I think I'm about to do. I need to do a. All right, I'll do this question. It'd be very unusual for you to get asked this one. This one is like mainly an honors level question, but we'll work with it, okay? Just to be sure that we covered it. Right. Now, it wants its error to be 5%. Does everybody see the error to be 5%? Okay. Now, for error to be 5%, all right? So that'll be what's it roughly? Actually, it wants the error to be plus or minus 5%. Okay, so that's how much you're allowed to be out by. Okay, so what we're going to say is this. What's the margin of error again? What's the formula? 1 over square root of n. And our error is allowed to be 5%. What's 5% in decimals? 0.05, okay? Our job is to find out what root n is. Did everyone see that? So root n is division on the right. What happens when it moves? Sorry, it's division on the left. What happens when it moves up to the right? Comes multiply. Would everybody be happy with that as a first move? Yeah? Next one. 0.05 is multiplication on the right. What happens to it when it moves to the left? It turns into division. Okay? Put 1 divided by 0.05 in your calculator, what will you get? Pretty sure it's 20. Everybody cool with that? Now, how do you get rid of a square root sign? Does anybody know? Square both sides. So anytime you square a square root will disappear. So what happens when you square root n? Just n. What happens when you square 20? Which is 400. Very unlikely question to come up. Okay, very unlikely. Well, at least I've shown you how to do one of them already, right? Now, the next question, however, is 100% likely to come up very soon. Is that right? So next question is the one you really want. Okay, and it's quite easy. It's easy marks. Okay, that one was hard. This one, easy. Okay, so here's what we're going to look at. Okay. In a study of 1,000 car crashes, it was found that 5,550 of them occurred within 10 kilometers of the driver's home. Car safety experts believe that 50% of all car crashes occur within 10 kilometers of home. They wish to test this hypothesis. Okay? Now, what the company is claiming is the null hypothesis. So, what is the company? What is the car safety experts actually saying? What are they actually saying? That it's 50% of car crashes occur within 10 kilometers of home. That's what H0 is. This is referred to as the null hypothesis. And what you say is 50% of car crashes occur within 10 kilometers of home. Is that okay? Now, does anyone know what the alternative hypothesis is? You're claiming that it's not 50%. So you say is the percentage of car crashes that occur within 10 kilometers of home. What do I write at the last? What's the last couple of words I say? Is not 50%. Part three. Let's make our confidence interval. Let's do what we've done in the last couple of questions. So, first thing you're looking for is your p-value or your proportion value, okay? And it's 5,550 divided by 10,000. And you can put that as a percentage if you want, because at the end of the day, the answer seems to be in percentages. So I'd say that's 55.5%, or yeah, I'd say it's 55.5%. Everybody happy enough with 55.5%? Or 0.0555. Okay, what's part four then? You're gonna make your comp, you're gonna get your margin of error. What's the margin of error? 1 over the square root of, anybody? 10,000. 1 over the square root of 10,000. Is it? Sweet. It's nice to have an easy one for once. 0.01. What's that in percent? So what's that in percentage? Yeah, it is 1%. So there's it in decimals and that's it in percentage, right? Now, Luke, we're going to make the confidence interval now. It's part 5. What do we reckon the confidence interval is? 55. So p-value, you have to add it on to 55.5% and take it away. Yeah. 56.5 and 54.5%. Now, what's the problem with the claim they made? Is 50% in this range? No. So what you say is at the 95% confidence level. See the way I'm using the wording of the question? See the way it says at the 95% confidence level? That's what we've done here. That interval is at the 95% confidence level. So you say at the 95% confidence level, we're rejecting their claim, aren't we? So we reject the null hypothesis. The null hypothesis is the claim that they're true. We reject the null hypothesis and accept the alternative hypothesis. Is that all right? 50% is not in the what's it called, the interval. What does 50% is not in the interval mean? It's not in the, or sorry, 50% is not in the range. What does that mean? 50% is not in the range. What would that mean? Yeah, it's not in between these two numbers. So therefore, at the 95% confidence interval, we reject the null hypothesis and we accept the alternative hypothesis. We okay with that? Right, let's try one more of these. I think we go for number 7. Okay, so number 7 is exactly the same thing. We're going to do step 1. I'll write down the steps for you. Step 1, H0. Write down what the null hypothesis is. Step 2, write down H1, what the alternative hypothesis is. Step 3, get your proportion statistic. I'll do that part for you. 57 out of 100. Is that okay? Step 4, your margin of error, which is 1 over root n. Step 5, your confidence interval. Okay? So you're going to add it on and take the margin of error, add it on and take it away. And then finally, step 6 is your conclusion. Okay, all that in one. H1. All right, what do you mean by the coin is fair? So the odds of getting ahead is 50%. Is that all right? Now what's H1, the null hypothesis? Oh, sorry. The odds of getting ahead is 50%. H1, the odds of getting ahead is not 50%. Okay? I know you can't really make it the product on the read it out. The odds of getting ahead is 50%. H1, the odds of getting ahead is not 50%. What about the p-value? 57 over 100 is 57%. Your margin of error, 1 over the square root of 100, which is 0.01, yeah? Or 0.1. Let's have a look. What? I think it's 10%, dude. Is it 10%? 0.1. So it's 0.1. And 0.1 is actually 10%. Okay. What's your confidence interval then? What's your confidence interval? What? Yeah, 47% all the way up to. Yeah. So because 50% lies in this region, we can't be sure that we have to accept the null. We can't reject the null hypothesis. Does that make sense? Okay. So what do you have to write at the end? I'll type it out for you. Okay. So what do we reckon at as the conclusion? Since 50% is included in this confidence interval, in their confidence interval, or since 50% is included in the range, okay, what's that? We have to use the language. We fail to reject the null hypothesis. We must conclude that this coin might be fair. And you're done. A good question for homework tonight would be the 2022 paper, isn't it, Luke? Paper 2, question 4, and question 10, wasn't it? And these two